Example 1. Helen and Jean both commence new jobs, each starting on an annual salary of $70,000. At the start of each new year, Helen receives an annual salary increase of $2,400. Let H sub n represent Helen's annual salary at the start of her nth year of employment. A. Show that H sub n equals 2,400 times n plus 67,600. Helen receives an annual salary increase of $2,400. This means Helen's salary forms an arithmetic sequence. D equals 2,400. This is H sub 1 equals $70,000. So H sub n equals H sub 1 plus n minus 1 times D. Substitution: $70,000 plus n minus 1 times 2,400. Simplify: $70,000 plus 2,400 times n minus 2,400 equals 2,400 times n plus 70,000 minus 2,400 equals 67,600. So H sub n equals 2,400 times n plus 67,600. At the start of each new year, Jean receives an annual salary increase of 3% of her previous year's annual salary. Increase of 3% means Jean's salary will form a geometric sequence, and R equals 1 plus 3% equals 1.03. Jean's annual salary, G sub n, at the start of her nth year of employment is given by this function. Given that G sub n follows a geometric sequence, state the value of the common ratio R. R equals 1.03. You can get from this information or from this information. We do know common ratio equals base. For this exponential function, base is 1.03. The start of year n, Jean's annual salary exceeds Helen's annual salary for the first time. Find the value of n. From the previous information, we know G sub n equals 70,000 times 1.03 to the n minus 1th power. H sub n equals 2,400 times n plus 67,600. Jean's annual salary exceeds Helen's annual salary means G sub n greater than H sub n. Substitution: 70,000 times 1.03 to the n minus 1th power greater than 2,400 times n plus 67,600. For this equation, since we are not sure how many solutions we have, we will solve this by graphing. Move everything to the left side. 70,000 times 1.03 to the n minus 1's power minus 2400 times n minus 67,600 greater than 0. 70,000 times 1.03 to the x minus 1's power. When you put a function into graphing, you have to change all the variables into x. Minus 2400x minus 67,600. Enter. Then we go to menu 4. Zoom out. We could see we got 2 roots. So figure out these 2 roots. Go to menu 6. 1. Menu again 6. Enter. Roots x equals 1 or x equals 10.8. If we want to get more accurate solutions, we need to go to menu, go to 8, change this into float 6. Okay, then we get more accurate answer. Otherwise, default is 3 sig figs. By solver, n equals 10.8, which means this n equals 11. C2, for the values of n found in part C1, state Helen's annual salary and Jane's annual salary, correct to the nearest dollar. G sub 11 equals 70,000 times 1.03 to the 11 minus 1's power equals $94,074. H sub 11 equals 2400 times 11 plus 67,600 equals $94,000. Let's go to D. Find Jane's total earnings at the start of her 10th year of employment. 10th year of employment, which means Jane has worked 9 years. So we are looking for S sub 9 instead of S sub 10. We will use this formula. S sub 9 equals, we already know J sub 1 equals $70,000. R equals 1.03. $70,000 times 1.03 to the 9th power minus 1 over 1.03 minus 1. Go to calculator, enter. $711,137.